Hello, in this video we will talk about the last problem tab in section 7.3, and that is when you see the x squared minus a squared format. Okay, here. So we are in the last problem tab in this section. So basically, when we get the problem, we want to find this format x squared minus a squared. Again, a stands for a constant. We don't want to mess it up with this one, the first problem tab. These two are different. Okay, so when we see this, we want to set x equals, set x equals a times secant data. So dx gonna be a times secant data tangent data d data. Okay, so I can plug in the substitution, and for square root x squared minus a squared is gonna equals square root a squared secant data squared, plug in x minus a squared, which is take a squared out, secant data squared minus 1. This part is tangent square, which is a squared tangent data square, which is a tangent data. Okay, so again we want to fix everything to be positive, so there is no negative situation here. I can get rid of the square root directly. Okay, so here is the sense how we set up the substitution and then how we plug it in. Okay, let's see the problem. First one, integral of the dx over square root x squared minus 49. Here x greater than 7, which indicates this part under the square root is greater than 0. So, okay. I firstly surely want to find the format, which is x squared minus a squared. Here, under the square root. So set x equals 7 secant data, a secant data, and dx is this is 7. dx is 7 secant data tangent data d data. Don't forget this d data. And again, I want to check if there is a limit to see if I need to change limit. There is no limit, so I don't need to change limit. Plug in into my substitution. 7 secant data tangent data d data, copy for the dx, square root 49 secant data square x squared minus 49. So this equals integral of the 7 secant data tangent data, a take the 49 out, secant data square minus 1 square root d data, and then this equals 7 secant data tangent data d data over 7 tangent data, right, this part. So it's clearly tangent data and tangent can be cancelled, 7 and 7 can be cancelled. So my next step is integral of the secant data d data. Okay, in the previous video I showed how to solve this one in the integration of the secant tangent only. So I want to apply my answer directly here, which is natural log secant data plus tangent data absolute value plus c, because there is no limit, so don't forget plus c. Again, I want to check my answer. I find here is data. I have to change them into x. So I go back to the very beginning to find the relationship I have. X equals 7 secant data, which indicates 7 multiply 1 over cosine data, right? Because 1 over cosine is secant, which means, okay, cosine data, if I say this, 1 over cosine data equals x over 7. I divide this 7 back to the x side, and then which equals 1 over cosine data. So I have cosine data equals 7 over x. Flip it over, take the inverse, and draw the triangle. Remember, we have the triangle method. Okay, data is here and the right angle here. So cosine data is actually this side over this side, 7 over x. So this side is x squared minus 49. And then what I need here is secant data and tangent data. I already know that secant data is, I can actually solve from here. I know that x equals 7 secant data, right? So secant data is simply x over 7. X over 7 solved from the beginning relationship here. And tangent data is find from my triangle, which is this side over this side, right? So it is square root x squared minus 49 over 7, and then plug into my answer. Natural log absolute value x over 7 plus square root x squared minus 49 over 7 absolute value plus c. Okay, so this is my final answer with no data in, which is fine here. Okay, so for this problem, I've surely want to find the format first, see which it belongs to. X squared minus a squared. Set up substitution and plug in. Check there is no limit, so don't need to change limit for this one. Okay, let's see the next problem. Let's see this one. Okay, so firstly I want to find the format, which part is applied to the format, which is here under the square root. 9x squared minus 25. I can rewrite it into 3x squared minus 25, which apply to the x squared minus a squared format. Something about x squared minus a constant square. Okay, and here again, x greater than 5 over 3, 5/3 is indicating what is under the square root always positive, so make the problem meaningful. Okay, so need to set up the substitution. So we know that in previous problems, x equals a secant data for this format, but for here, what is under the square is 3x, right? So 3x equals, instead of this single x, 5 secant data, a secant data. So solve for x equals 5/3 secant data. Then dx gonna be 5/3 secant data, tangent data, d data, don't forget this d data. And then check there is no limit. I don't need to change limit, so plug in my substitution. Square root 9x squared, which is here, I mean 3x squared, right? that is simply 25 secant data square minus 25. So here x cubed, again, what is outside the square root, outside my format actually, it not belongs to the format. Here x squared minus a squared, right? It's outside. So I simply apply substitution. Later I'm gonna solve it. So x cubed is 5/3 cube secant data cube. Okay. Dx here copy 5/3 secant data tangent data d data. Okay. So let's solve this part first and then do some simplification. A 5/3 cube secant data cube. This one is simply 5 tangent data. Okay. You take the 25 out, take square root, and secant data square minus 1 give you tangent data, and then square root, solve it. Multiply 5/3 secant data tangent data d data. Okay. This 5/3 can be cancelled out with 1 at the denominator. So here left is 2. 5/5 square. Okay. Again, secant data cancel out 1 from here. Okay. I want to take the constant out, which is 5 from the top. Multiply 3/5 square. Okay. Because this is at the denominator position, if I want to multiply it out, I'm gonna take the inverse, right? So multiply integration of this is tangent, here is a tangent, so tangent data square over what is left here is secant data square d data. Okay. So I want to simplify this constant first. Again, this 3/5 is because 5/3 is at the denominator. If I want to multiply it, I have to take the inverse. So make it clear. What is on top is 9/5. Just compute this. And for tangent square over secant square, substitution seems doesn't work. Rewrite it. So sine data square over cosine data square gives me tangent square. Multiply. We know that secant data is 1 over cosine data. So if I want to multiply it out, I'm gonna take the inverse, right? So dy secant is actually, if say 1 over secant data, it is cosine. So multiply cosine data square d data. So these two can be cancelled out, which equals okay, right here 9/5 sine data square d data. Okay. So this is we should be very familiar. Even powered key formula is 1 minus cosine 2 data over 2. Okay, plug in the formula. So I'm here now. 9/5 by integration 2 divided by 1 minus cosine 2 data d data. Okay. Take the constant out, 9/10 integration 1 d data minus integral of the cosine 2 data d data. I take the 1/2 outside and then split the integral into two integrals. So 9/10 multiply data minus here 1/2 sine 2 data. Yeah. Okay. So what I can do is I know it looks like an answer if I want to plus C here. It looks like the answer, but I know that I'm gonna substitute the X back for data. And if I want to use the triangle method, I put data here, right angle here. I can get everything sine, cosine, tangent, cotangent for simply data, right? But it's not for 2 data. Here is sine of the 2 times data. So my triangle couldn't apply for a doubled data. I have to rewrite this part again, which is 9/10 data minus 1/2, copy the constant, by, we know that sine 2 data equals what? 2. Sine data, cosine data, right? Plus C. So I cancel these 2 out. This is 9/10 data minus sine data, cosine data, plus C. Okay. So now everything is about single data. I can use the triangle method. Data and the right angle. Go back to see the, okay, here. X equals 5/3 secant data. So I rewrite it into 3x/5 is secant data. I take multiply 3 here and then divide 5, which is also what? 1/cosine data at secant data. So cosine data, I know that is flip this over 5/3x. Okay. So for data, cosine is 5/3x. So this side gonna be 9x squared minus 25. Okay, so I want to plug in, rewrite my answer. I'm gonna erase here. Equals, okay, 9/10 data. I randomly pick one, so I say, since I know the cosine, I'm gonna use the cosine. Arc cosine 5/3x. Okay, that implies for this data. Minus sine data is square root 9x squared minus 25 divide 3x by cosine data right here, 5/3x. Okay, and then plus C. So this is my answer, this part. I surely can multiply this 9/10 in, but I don't necessarily need to. And you can also multiply these 2 terms together, like 9x squared on denominator and 5 square root 9x squared minus 25, put them together. But it doesn't matter for this format, as long as you know how to solve it. So this is my answer. Okay. For this problem, again, I actually want to find the format first, which is here, under the square root. But what is outside the format, like this x cube, I don't worry about it. I simply plug in the substitution, and then surely you can solve it. And don't forget this triangle method. Okay, let's see the next problem. Let's see this one. After I get in the problem, I can easily find the format x squared minus a squared. I have to notice here is limited, so I'm gonna change the limit for my substitution. But for this problem, I'm gonna show you how to find the limit for data in a easier way compared with before. So let's set up the substitution. Say x equals 8 secant data. Dx is 8 secant data, tangent data, d data. Change limit. I know that x greater or equal than 8 square root 2 less equal than 16. Okay. So for example, if in other formats, problem tabs, we set x equals a sine data or something else, tangent data. But I'm saying in another case, for example, I say, okay, a is a sine data, not this one. So 16 8 square root 2, for example, here. And we surely know that our a always bigger than 0 because a sine data and a square, we only take the positive number to compute. What I need to do is always simply cancel out this a, this constant, both sides, and then I can solve for the data's value directly, right? Equals to different numbers, less equal than or greater than different numbers. So it is fairly simple, but in this problem tab, we are actually working with the secant. Say, let's say this. If I plug in 8 secant data less equal than 16 greater or equal than 8 square root 2. Of course, I can cancel out 8 first, which is secant data less equal than 2 greater than square root 2. Okay. I'm not really very familiar with the secant value, but I know cosine better, so I want to rewrite it into cosine data divided by 1, which is such a way. Okay, since there is an inverse, I'm gonna take inverse both sides later, right? But I have to be careful because if I take the inverse, the bigger number probably gonna be smaller, and the smaller number gonna be bigger, which means you have to flip it over, change the side. Okay, I need to be very careful here to change the direction. After solving this, okay, say cosine data less equal than 1 over square root 2 greater equal than 1/2. We know that cosine is here is pi, is a decreasing function between 0 to pi, and then it's gonna increasing again to 2 pi. The angle we are picking always the simplest ones for data. So for decreasing function, the bigger number gonna give me a smaller angle, and the smaller value gonna gives me a bigger angle, which means I'm gonna flip things again to find the limit for data, which sounds complicated and but it makes sense, right? For decreasing function, the corresponding value is bigger, the variable data itself should be smaller. That's the idea, but I surely don't want to solve in such a way. If I am careful enough, I can do that, but I want to show how to do it in an easier way. Okay, I know that x is in this region. I rewrite it into x belongs to 8 square root 2 to 16. These two means the same thing, exactly same thing. X belongs to this region. Okay, so what I need to do right now is simply pick these two endpoints based for x, right? So I say x equals 8 square root 2. This is my first endpoint for x equals 8 secant data. This is my substitution. And then solve for secant data equals cancel out this 8 square root 2. 1 over cosine data is square root 2. This is secant. Cosine data is simply 1 over square root 2, which also can write into square root 2 over 2. Data, here I want to, as we did before, always pick the simplest one, easiest one, and gives me the positive number. We don't consider any negative or complicated case, so here it's just simply pi over 4. Positive gives me positive value and simple. Okay, so since 8 square root 2 is the end value for ax, this pi over 4 is also an end point, the extreme value for my data. I find the one end point for data. I'm going to do the same thing to find the other one, which is 16. Pick the second end point equals 8 secant data, which is also x, right? So secant data is 2. Okay, solve for data. So 1 over cosine data is 2, right? Secant equals this. Cosine data is 1/2. And then data is simply pi over 3. Pick the simplest one. This is my second endpoint for data. I'm finding the region for data is because my new variable here is data, right? Following D. Sorry. And now what I need to do is simply to compare which number is bigger. So surely here pi over 3 is bigger. So data belongs to pi over 3 to pi over 4. So that is my limit for data. These two are my two endpoints for data. Okay, this way is fairly simple. You just pick endpoints, plug in, solve for simplest angle, and then that's the limit. Okay, and after finding the new limit, plug in substitution. That is pi over 3 to pi over 4. dx is 8 secant data, tangent data, d data, a square root x squared 64 secant data squared minus 64. Okay, sorry. Simplify it. Pi over 3 over pi over 4, 2 pi over 4. 8 secant data, tangent data, d data, over, this is simply 8 tangent data, okay? So 8 can cancel with 8, tangent cancel with tangent, that is pi over 3 to pi over 4 secant data, d data. So this one we have solved before. Okay, so I apply the answer directly. Natural log secant data plus tangent data to from pi over 4 to pi over 3. And then plug in the numbers. Natural log secant pi over 3 plus tangent pi over 3. Plug the bigger number into every data position minus plug in smaller number into every data position. Secant pi over 4 plus tangent pi over 4. Okay, absolute value. Okay, secant pi over 3 is 1 over cosine pi over 3, right? That is secant pi over 3, which is 1 over 1/2. That is 2. So natural log 2 plus tangent pi over 3 is square root 3 minus natural log tangent. We remember this triangle, special angled triangle, pi over 3, pi over 3, sorry, pi over 6 here, pi over 3, 1, 2, square root 3. Okay, find the tangent value. Natural log, okay, secant pi over 4 is 1 over cosine pi over 4, right? So secant is, that is 1 over square root 2 over 2, simply square root 2. Square root 2 plus tangent pi over 4, 1. Okay, so this is my answer. Here is fine, but if I want to simplify it one more step, I can rewrite it in this way: a divide square root 2 plus 1. Okay, so because here is a negative value, negative sign. Okay, so this is my answer. The integration part, apply substitution part, is not difficult, but for a secant substitution, like especially for this problem format, x squared minus a squared, when you use secant, the easy way to find the limit for data is to apply two endpoints and then compare with the two angles you find. That's gonna be data's region. Okay, that's this one. Again, a brief summary for this problem tab. We surely, after we get a problem, we want to find if something looks like this: x squared minus a squared. I set x equals a secant data. Later, after we plug in, that is a squared secant data square minus a squared. Take a squared out, secant data square minus 1. This is tangent data square. Okay, so a squared tangent data square. That's how you simplify it and how you apply the substitution. Again, if there is a square root, outside the square root, we don't worry it for the beginning. Just simply plug in the substitution. So, and for previous two problem tab, you surely want to know how to substitute, which they are a squared minus x squared and a squared plus x squared. Okay, these two. And this is also can write into x squared plus a squared. These two are same. So however, a squared minus x squared is surely different with x squared minus a squared. Okay, we don't want to mess up. And the substitution method and how to apply theory behind that is in previous videos. You just check with that. Again, triangle method, we don't want data in the answer, so change everything back into x by using proper triangle method also showed before. Number 3 is if you use substitution, you have to change limit if there is a limit integral. And for x equals a secant data, we know that we're gonna change things into cosine. 1 over cosine greater than some number less equal than the other number. We surely want to apply the easier method, which I just mentioned. Say write x belongs to number, the region for x, and the a secant data equals the first endpoint, and the a secant data equals the second endpoint, which is surely just x, right? Based on these two extreme values for x, find your extreme endpoint for data. and then compare which one is bigger, find the limit for data. That is a easier way for secant data. Okay, and be careful with changing limit. Yes, your limit should be corresponding to the variable you are using. So that's for this problem tab. Wish it is clear, and see you in my next video. Thank you. Bye bye.